Good morning, everybody, and welcome to Math on this wonderful Tuesday. Here's what we're working on today. Fractions and story problems, part 2. Here's what you're going to need. Here's the I cans down here. I can create equivalent fractions, and I can use a reading strategy to accurately solve math story problems. We've got a lot to cover today, so I'm just going to jump right into it with my favorite no. This is a math practice that I happen to absolutely adore. And it's one of my favorite things to do in math because it lets us take a look at and do some error analysis, and two, celebrate all the great mathematical thinking that's happening even in a problem where you don't have the accurate and correctest answer. Okay, so here's my favorite no from yesterday's exit ticket, which I loved. I'm going to give you the problem here. It says this: it is the finals of Glenview Elementary's pie eating contest, and all the finalists are from Mr. Taco's class. After 10 minutes of furious and messy eating, the finalists stand up from their chairs, and the judges get to inspect and see who ate the most pie. And here are what the judges saw. Cole ate 4/5 of the pie. Lily ate 2/3 of the pie. And Emmanuel ate 3/4 of the pie. Who ate the most pie? Who ate the second most? Who ate the third most? And how do you know? Now, this was tricky for some people, and we saw some really, really good mathematical thinking and some reasoning. My favorite answer of all, possibly even more of a favorite answer than the correct answer, was this one. We saw multiple people have this great idea. Well, they all have one piece left, so they all ate the same amount. I love this. I love this because it shows a lot of nuance and a lot of really, really strong thinking with fractions. The mathematicians who answered this, who gave this answer, immediately saw some patterns. They noticed all of the numerators are one less than the denominators, meaning if you add one more of that denominator, you're going to get 4/4, 3/3, or 5/5, meaning we would all have one. So they did a great job of going, oh, they ate everything but one piece. Excellent work there. I 100% agree. And knowing this, that they all have one piece left, or one of their denominator left, allows you to take that last step and figure out the full and correct answer. Okay? Because the one thing that's missing from this really, really great piece of reasoning is, are these pieces, I definitely 100% agree that they all have one piece left, but are those pieces the same size? There's a great joke, I don't know if I've told it already, there's a great joke of Yogi Berra, who is a baseball player and one of the more quotable people. He said once, or as legend has it, he said he went to a pizza place and he said to the waiter, he goes, can you cut my pizza into 4 pieces? I don't think I'm hungry enough to eat 6. And this is what it's getting at right here. This idea of, well, if I cut the pizza into 4 pieces, it's still the same amount of pizza, just each piece is bigger. So let's think about this and let's put these in terms of how much pie is left. So if Cole ate 4/5 of his pie, Cole has 1/5 remaining. If Lily ate 2/3 of the pie, Lily has 1/3 remaining. And if Emmanuel ate 3/4 of the pie, Emmanuel has 1/4 remaining. Now, there is all ones in the numerators. I 100% agree with that. But remember, our denominator says, or what our denominator notates, is it's notating the size of the piece. How many equal pieces is our whole quantity divided into? Okay, in this case, it's 1 pi divided into 5 equal pieces, 1 pi divided into 3 equal pieces, and 1 pi divided into 4 equal pieces. Okay, if we were to draw these out in fractions bars, it might look, I'm going to grab my black marker, it might look something like this. So remember, this is the pi that is left. The rest of it has been eaten. So here's our fractions bars. It's a rectangular shaped pie, just so we can see it a little easier. Okay, I'm going to divide Cole's into fifths. I'm going to divide Lily's into thirds. And I'm going to divide Emmanuel's into fourths. Okay, now I'm going to shade in 1/5. That's the amount of pie Cole has left on his plate. I'm going to shade in 1/3 because that's how much Lily has left. I'm going to shade in 1/4 because that's how much Emmanuel has left. And if you take a look, you can see that even though there are one of each piece remaining in this pie, each of these pieces are different sizes. Cole's is the smallest. And we can use our deductive reasoning here and say, if Cole has the least amount of pie remaining, and they all started with the same amount of pie, then Cole must have eaten the most pie. And now we can compare Emmanuel's and Lily's. Is 1/4 or 1/3 less? Which one has less value? Because remember, we're thinking about the less pie is remaining, the more pie that they ate. And we can see here 1/4 is less than 1/3. So that must mean Emmanuel ate more pie than Lily. So we would have number 1, number 2, and number 3. So this favorite no is outstanding mathematical reasoning. And all that was missing was this one piece of thinking, they all have one piece left. So whoever has the smallest piece left must have eaten the most pie. In this case, it was Cole. All right? Wonderful, wonderful work on that. Again, I love my favorite no's because even in a situation where you don't arrive at the correct final answer, the accurate final answer, there's still so much outstanding and accurate math you're doing along the way that is just as important as the final answer. Okay, math's not. It's in some ways it's about the end product, but it's also about the thinking that goes on to get to that end product. Okay, let's go to some of our practice problems here. Here's our first one for today. It says this. Remember, we're going to do our 3 reads. Let's go back to the full cam and just briefly review the 3 reads. The first read is really just focusing on the situation. What's going on in the story? Visualize the scenario you are given. I saw a lot of great mathematics yesterday and a lot of great thinking where people actually drew out the situation, made little doodles for themselves of what's going on. And it's going to be really, really helpful, okay, to draw it out and think about, okay, if this is too long, this is too short, this is right in the middle, okay? Read number 2, we're thinking about, okay, what numbers do we hear and what do those numbers represent? Okay, do those numbers represent something we have to add? Do those numbers represent something where we have to find the difference? Do those numbers represent something that we don't actually need in the problem, right? One of the things with this problem from yesterday, I think it was Natalie brought it up in small group. She said, well, not only are these numbers, these quantities in that problem, but the number 10 is in the problem because they had 10 minutes to eat their pie. Great observation, okay? And often that's what we, our big word, one of my favorite words is superfluous. That in that case, great to recognize that number, and then doubly great to recognize, okay, I know that's a number. I also know it doesn't factor in, I'm not going to need that number to solve the problem. Often there will be superfluous information or extra information in a math situation that you're not going to need. Okay? So what numbers do I hear? What do those numbers represent? And then last, think about the question. What are the unknowns in this problem? And what operations might help me solve that unknown? Okay? So let's go to our first practice problem today. It says this: Pasco has been hard at work knitting scarves for his friends. He wants to make each scarf 2 feet long. He checks the length of his latest scarf and measures it to be 1 1/8 feet. How much more must he knit to get this scarf to be 2 feet? So think about the situation first. What's going on in this story? Don't worry about the numbers. Don't worry about, am I going to have to add, subtract, multiply, divide? Just think about the story. Visualize that story. Pasco's knitting some scarves. That's it. He's working on one right now. He knows it's not long enough yet. So he's going to have to knit some more. That's all for the first read. Okay, and we're visualizing that. We're keeping that in our mind, our mathematical mind here. Pasco's knitting some scarves. He's working on his latest one, and it's not long enough yet. He's going to have to knit some more. Okay, second read. Let's focus on the quantities. Pasco has been hard at work knitting scarves for his friends. He wants to make each scarf 2 feet long. He checks the length of his latest scarf, and it measures to be 1 1/8 feet. How much more must he knit to get this scarf to be 2 feet? So what numbers, what quantities do we hear in this problem? I'm going to type it. So we have our 2, and what does our 2 equal? Our 2 equals the length of a finished scarf, right? And then we've got 1 and 1/8. And what does that equal? That equals how long his latest scarf is now. Okay, oh, I'll move my face out of the way there so you can see it. Ta-da. There we go. Okay. So now we know, let's put it together now. We know Pasco's been knitting scarves. His latest scarf isn't long enough. It's 1 1/8 feet. So he's got to knit some more until he gets to 2 feet. So that leads us naturally into that question, right? Third read, think about the question. What are the unknowns? Pasco has been hard at work knitting scarves for his friends. He wants to make each scarf 2 feet long. He checks the length of his latest scarf, and it measures 1 1/8 feet. How much more must he knit to get this scarf to be 2 feet? So what's our question here? What operation might help us in this situation? So we know we don't have enough and we need more. That sounds like adding, doesn't it? Adding, or what's the inverse of addition? Subtraction. Okay, so let me erase the board and then we'll do it up here. So here's what we've got. We've got 2 is the total length of the scarf, 2 feet, equals 1 1/8 plus something. Would you agree? 2 equals 1 1/8 plus something. There's a couple ways we can do this, right? We could use that inverse equation and go, oh, well, if 1 1/8 plus something equals 2, then 2 minus 1 1/8 will get my answer. Right? We could do it with our improper fractions method. How many eighths equals 2? Find our 8 and our 2, and it's 16 eighths. So maybe we can convert this into 16 eighths equals, putting ors, because you can do them in multiple ways, equals, how many eighths does 1 1/8 equal? Well, I know 1 equals 8 eighths, plus that 1 more equals 9 eighths, plus something equals 16 eighths. Okay? And I'm seeing it in the chat already. Some of you are really starting to think about it, right? 16 equals 9 plus what? Equals 9 plus 7. Okay, or 2 minus 1 equals 1. And then 1 minus 1/8 equals 7 eighths. So our final answer here is 7 eighths. And what's our unit? We're in feet. Okay, so again, this is where the 3 reads comes in handy. Okay, everybody. I do have one more problem, but I think, actually, in the interest of time, I'm going to save it. So, on your exit ticket, there are 3 different problems to try. Again, explain your thinking for each one. Okay, giving an answer is great, but then also explain your thinking and tell us how you got there, because we can learn from you in a lot of ways. If you came up with a strategy to solve this problem in a way that nobody else has thought of, that's worth teaching everybody else. Okay, if you came up with a strategy that is really good mathematical reasoning, but is kind of a my favorite no, again, that's something we can all learn from. All right, so make sure to explain your thinking. I'll warn you, the third one's a little bit of a challenge. So if it's tricky, just try your best with it. No penalty for a wrong answer. Okay? And good luck. If you have questions, come to small group. It's starting at 11 o'clock. Otherwise, I will see you back here at 12:30 for Writers Workshop. Take care and happy math, everybody.